Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again after months of spouting gibberish. The spaceship left the solar system in 2012 and is currently more than 15 billion miles from Earth.
In the frigid darkness more than 15 billion miles from Earth, where sunlight is a pale whisper and the familiar planets lie far behind, NASA's Voyager 1 spacecraft has just delivered a revelation that has stunned astrophysicists and planetary scientists alike. After nearly 5 decades in flight, the robotic pioneer has reached a realm of space no human-built machine has ever visited, and made a discovery so unexpected, so at odds with our current understanding, that some scientists have quietly begun to rethink the very structure of the solar system itself. Before we start, smash the like and subscribe buttons for more updates. The data came slowly, transmitted across the yawning abyss of interstellar space over the course of several months. Voyager 1, still valiantly operating on its radioactive power supply, sent back a series of readings from its plasma wave system and magnetometer that suggested something extraordinary. A new, unidentified form of magnetic structure in the heliopause, the boundary region that separates the solar wind from the interstellar medium. Until now, this outer skin of the solar system was thought to be chaotic, but generally well understood. A region where solar particles are slowed, heated, and finally deflected by the interstellar plasma. Yet what Voyager 1 detected was not the chaotic turbulence that models had long predicted. Instead, it was a highly ordered, stable magnetic field pattern, one that appears to ripple and pulse like a living membrane. At first, the phenomenon seemed like an error. Voyager 1 is, after all, operating well beyond its intended lifespan. Scientists cross-checked the instruments, then compared the data with Voyager 2, which is on a similar but not identical trajectory, tens of millions of miles away. But the signatures were real. Something at the edge of the solar system, just beyond the reach of the sun's dominant influence, was behaving in a manner utterly contrary to decades of solar physics. This wasn't merely an anomaly, it was a phenomenon, and perhaps even a clue to a deeper layer of physics that had remained hidden until now. The newly observed magnetic structure exhibited oscillations on a scale and frequency that bore no resemblance to the expected solar or interstellar processes. What made this even more baffling was the energy signature. The field lines appeared to align in a quasi-crystalline lattice, forming regular intervals that should not exist in a region governed by high-temperature plasma and chaotic particle motion. The heliopause was supposed to be a turbulent transition, more like a roiling river delta than a precise architecture. Yet what Voyager 1 had uncovered looked more like the engineered output of an ordered system, geometric, coherent, and disturbingly consistent across several observations. This is where the implications become even more unsettling. If the outer boundary of the heliosphere contains structured, repeating magnetic patterns, what force could possibly be shaping them? One early hypothesis considered gravitational interactions with dark matter particles, which might form filaments or scaffolding on cosmic scales. But this would require dark matter to behave in ways no current theory supports. Another camp of researchers proposed that the structured fields could result from an interference pattern between the sun's magnetic output and an as-yet unidentified interstellar field. If that were true, it would imply that the sun's influence extends much farther and in much more complex ways than previously imagined. Whatever the explanation, the discovery has opened a profound new window into the nature of the boundary zone that encases our solar system. For decades, scientists envisioned the heliopause as the endpoint of solar influence, a kind of ragged outer wall. Voyager 1's data suggests instead that the wall is not just permeable, but possibly interactive, and not random but ordered. It raises the possibility that the sun and the interstellar medium are locked in a kind of electromagnetic dance, shaping each other across space in ways no one predicted. The solar system, it now appears, may not end in a blur of hot gas and stuttering magnetism, but in a membrane, a dynamic, structured interface, as if the sun itself is wrapped in a kind of cosmic skin. The consequences of this are immense. First, it calls into question our understanding of stellar boundaries, not just in our own system, but throughout the galaxy. If such ordered magnetic fields are common at the edges of star systems, they could profoundly influence how matter and energy flow through interstellar space. This would affect everything from the formation of new stars to the distribution of cosmic rays, those high-energy particles that bombard Earth and play a poorly understood role in climate, biology, and even evolution. It could even provide a mechanism for subtle long-distance communication between stellar bodies via magnetohydrodynamic signaling, a speculative concept until now lacking any basis in observation. Then there is the tantalizing, albeit controversial, question of intentionality. Some theorists, far outside the mainstream but now receiving increased attention, have long speculated about the possibility that highly advanced civilizations might manipulate magnetic or gravitational fields on vast scales, leaving behind detectable artifacts not of matter, but of field structure. Could the ordered patterns Voyager 1 has found be a kind of signature, a boundary marker not of nature but of design? Most scientists scoff at the idea, yet admit privately that the precision of the magnetic lattice is unnerving. It is, at minimum, a puzzle, one that does not comfortably fit within any current physical framework. Adding to the intrigue is the behavior of cosmic rays near the boundary. Voyager 1 detected sharp discontinuities in the flow of high-energy particles as it crossed through this structured field, suggesting that the magnetic pattern may act as a kind of selective filter. Certain energies and particle types were allowed through, others deflected, almost as if the field were performing a form of passive sorting. Such a mechanism has no analog in natural astrophysical processes as currently understood. If confirmed, it would imply that the heliopause is not merely a passive boundary, but a dynamic interface, capable of regulating what enters and exits the solar system. Another layer of mystery emerged when Voyager 1's instruments picked up low-frequency radio emissions not previously observed in that region. These signals appeared modulated, not random but shaped by some external influence. Scientists initially assumed they were remnants of solar activity, but the timing, intensity, and directionality didn't match any known solar events. The emissions coincided almost precisely with Voyager 1's traversal through the most structured regions of the magnetic field, prompting some to suggest they are a natural byproduct of the magnetic lattice itself. If that is true, it opens the door to a form of plasma resonance at interstellar scales, a phenomenon that could have applications in everything from communication theory to propulsion physics. One of the most immediate consequences of this discovery is the pressing need to reframe the heliosphere not as a closed bubble, but as a semi-permeable membrane, a living boundary that shapes and is shaped by its environment. This would require an overhaul of countless models, from those used to simulate stellar winds to those that forecast cosmic radiation exposure for interstellar missions. It could also reshape strategies for future space probes. Instead of aiming to break through the edge of the solar system, scientists might instead attempt to study its layered structure in detail, perhaps even sending probes to surf the heliopause's magnetic architecture the way a satellite orbits a planet. Moreover, this finding may alter our timeline for interstellar exploration. If the boundary of the solar system is not a chaotic blur, but a region of structured field interactions, then navigating through it may demand new forms of spacecraft shielding or guidance. The highly ordered fields could play havoc with traditional navigation systems or conversely, provide a new means of orientation. Spacecraft could potentially read the magnetic patterns like a map, or be steered by them, if the field proves responsive to certain inputs. This discovery may also influence how we search for life elsewhere. If other star systems exhibit similarly structured boundaries, then those boundaries could act as filters or regulators for incoming and outgoing materials. It's conceivable that such structures affect the transport of organic molecules, cosmic dust, or even simple life forms, suggesting that the heliopause plays a subtle role in shaping the biospheric potential of planets within. Life, in this view, is not just a matter of what happens on a planet, but also what enters and exits the protective bubble surrounding its star. There is the existential shock of the discovery. Voyager 1 has traveled farther than any other human object, and in doing so, it has touched the invisible skin of the solar system and found that it is not what we thought it was. The implications extend beyond science and into the philosophical. For centuries, humans have peered into the sky and tried to draw boundaries. Earth and sky, atmosphere and space, solar system and stars. Each boundary has turned out to be more complex, more mysterious than the last. Now, at the very edge of our sun's domain, we find not emptiness, but architecture. Not chaos, but structure. This does not mean we have found proof of alien intelligence, or discovered a new form of matter, or rewritten the laws of physics. Yet. But it does mean that the universe remains full of surprises, especially where we thought we had already seen everything there was to see. Voyager 1, drifting silently in the dark, has reached what we thought was the end, and found instead a new beginning. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Voyager 1's impossible discovery at Solar System's edge? We want to hear from you. Thank you for watching and see you next time.